So we got x is equal to negative. All right, this is to do now. Solve for x, and then just look at this question and see if you can figure out what I'm talking about. When this equation started out, what I'm asking here is what was the first thing that was done to the x in this equation above? I'm not talking about when you solve it. In order for this equation to come into being, it actually started out as just this thing. And then different things were done to this equation to make it look like this, right? Like somebody created this equation, right? It started life as like a little thing like this, and it kind of grew to be this. When we solve it, we're sort of like undoing all the things that were done to it to get to there. Say again? Well, what was the first thing that was done to it? To this x? Not added a. No, I'm not talking about solving. I'm saying if you just look at this equation here, it started out as just an x. What was done to the x first? Was it multiplied by -6 or was it -8? Was an 8 taken away from it? Go by PEMDAS.
Wait,
Huh? It was multiplied by -6. Because
yeah,
PEMDAS says multiplication is higher up. We're not talking about solving now. Let's start it with something new. I'm gonna actually just go over this in the lesson. Okay, you'll see what I'm talking about. Let's, instead of this equation, let me use another equation, and I'm actually gonna do this stuff, and you'll see what I'm talking about. But basically, what was first done was it was multiplied by -6, and then an 8 was subtracted from it, which you'll see more in a second, okay? Because you have to go by PEMDAS rules. When you solve, you're actually not going according to PEMDAS. When you solve, you're actually going backwards. Because PEMDAS says multiplication is more important, but yet we hit that minus first. We hit the subtraction first when we solve, right? Because when you solve, you're kind of actually going backwards. You'll see what I mean in a second, okay? Anyhow, we got x is equal to -7. Everybody good with that? How would you check to make sure that that's the right answer? Just to be double sure. Say again?
Substitute.
Substitute, good. So what's -6 times -7? Huh?
Wait, -6 times -7 is 42.
It's 42. And then what's 42 take away 8? 34, which is what we wanted it to be, right? So we know that we solved it the right way, okay? That's how you could actually, like if you forgot about the negative, if you put the 7 in, you would have got a -42 minus 8, which gives you -50, which does not equal 34. So that, like when you check it, that's how you can make sure you did it right? Okay, let's just go on to what we're going to do today, and I think it'll make more sense. Can I erase this then? Everybody? Okay. So we're going to grow our own equation right now, okay? We're not growing weed, don't get excited, we're growing an equation, okay? Give me an x. Somebody give me some x. What do you want to start with?
2x.
Give me a number.
2.
7? We're going to grow our equation. When you grow something, what do you have to start with? No, before the dirt. That comes next.
Seed.
A seed, yeah. Come on, you guys don't know what seeds are? Come on. This is a seed. So, then we're going to put it in the dirt. And what else do you need to make the plant grow? Some water. Water, good. We'll put some water on here. H2O. So,
It's like art class.
give me a number. We're gonna multiply this x by some number. Give me a number.
5.
5? Now, whatever you do on one side, we have to do the same on the other side. So what's 7 times 5? All right, and now we're gonna add some sunlight. So let's go outside for a while. No. You want to add or subtract a number?
Subtract.
Subtract what? Give me a number.
17.
Good. So we have to subtract 17 from both sides. 35 take away 17 is, I think it's 12.
Yeah.
Is that right?
Yeah, it's 12.
Okay. So we just grew ourselves a nice equation. And we know that when we solve this, well, it's going to equal 7. X is going to equal 7. But yeah, when you plug it in, you get 35. 35 minus 17 is 12. But do you see how we grew our own equation here, starting from the seed? And what's nice about this is, let's say you wanted to make some equations to practice solving equations on. If I just started like making up numbers, chances are my x is not going to be a whole number. It's going to be like a decimal or a fraction or something. But when you do it like this, you're always going to get a whole number or an integer as your answer. Okay? So now that we grew our own equation, to solve it, right? Well, first of all, what was the first thing that we did to this equation? What was the first step we did to go from here to here? Huh?
Multiplication.
Multiplied by? That was the first thing that's done. Actually, let me call this what was done to the x. So the first step is we multiplied by 5. What was the second thing we did? Say again?
Wait, time out. Are you sure it's 12?
Am I sure what's
Not
12?
18?
35 take away 17?
Not 18. I'm on bugging.
I don't know.
It's not 18.
This?
Yeah.
No, I think it's 12.
Come on, shall we pull out the calculator?
What's check it for me. What's 35 take away?
It's 18.
Is it? Okay. It's 18?
Yeah.
35 take away 17?
It's 18.
I know I wasn't
Good. Okay.
bugging. I know I wasn't bugging.
Good. No, I'm glad you said that. If you ever see me make a mistake, man, definitely jump on it. Okay, it's 18. Good. So what was the second step? After we multiplied both sides by 5, what do we do here?
Subtract.
We subtracted 17. Okay? So this is what was done to the x, okay? So this is in order of PEMDAS, right? You notice the multiplication came first and then the subtraction. When you solve for x, let's say we didn't already know what x is, and I just gave you this, and I said solve for x. Basically, you have to do everything in the opposite direction, okay? Like up here, we started with the seed, and we got an equation, but when you solve it, you're starting with the equation, you want to get to the seed, right? You can think of like this as the present, right? Think of it as like a piece of gold jewelry or something, right? And somebody's going to give you this nice gold watch. Let's call it gold watch, okay? And what do? If you're going to give a present to somebody, you want it to look nice, so you know, you might wrap it up in like that tissue paper. It might have a nice box. You put it in like a box, right? Then you're going to wrap it up with nice wrapping paper, and maybe you might put like a bow on it at the end, so you have this nice looking thing, right? So the person who gets this present, what do they have to do? How do they get to the
Do
present?
everything backwards.
They have to undo all of those things in the opposite order, right? First, you got to untie the ribbon. Then you got to rip off the wrapping paper. Then you got to open the box, and then finally you like open the tissue paper to get to the thing, right? It's the same reason here. That's why we're not using PEMDAS when we actually solve it, because we're not making it. We're like undoing it to get to the thing that's inside. So it's like you're undoing everything in the opposite order it was done to. Okay. So to solve, you're going to take the last thing here and make it the first thing over here. But we have to use the opposite operation so it cancels out. So what's the opposite of subtract? So I'm going to say the first step is we're going to add 17. Okay? Then we go upwards. And we use the opposite. What's the opposite of multiplication?
Division.
So I'm going to say divide by 5. And this actually gives you the step-by-step instructions of how to solve the equation. Guys, you got to sit up. Khalil, gotta sit up. No, you gotta put your head up. And watch. So first we're gonna add 17 to both sides, right? That's what it says. So we did that. Now it says divide by 5. Okay. And this is why when you solve things, you're actually kind of going in backwards order, because you're undoing all the things that were done to that x to give you that equation, okay? You get the concept? Now, if I just give you this, you don't have to write all of these steps because you know how to do this. But when they get a little bit more complicated, this only has 2 operations. What if you have an equation that has like 4 operations? Sometimes you get confused about what do I do first. If you actually do this and then just reverse it for this and follow these steps, it works every single time, no matter how many operations you have, okay? That's when it really comes in handy. So we have the equation 5x plus 3 equals 23. So first, we're going to say, all right, what was done to x?
It was multiplied by 5.
Multiplied by 5. That had to be done first because PEMDAS says multiplication is bigger, is more important. So multiply by 5.
You write that down?
Yeah, write that for A. Right, in 5A it says list the operations that have been done to the variable x. That's what we're doing. Then after it was multiplied by 5, what was the next thing that was done to the x?
Added by 3.
Yeah, add 3. So now to solve, Khalil, you got to take the hood off. To solve, we're going to, the last thing here becomes the first thing here, and you use the opposite operation. Instead of add 3, subtract 3. Huh? Yeah, write this for B, I'm sorry, yeah. So this becomes subtract 3. And instead of multiply by 5, becomes what?
Divide.
Divide by 5, good. And this actually gives you the instructions, and then you just go ahead and solve it following that. Good. All right. You subtract 3 from both sides, you get 5x equals 20, and you divide by 5, you get 20 divided by 5 is 4. You get x equals 4, right? All right, let's go down to exercise 2. Here's where it gets a little bit, more useful because we get a little bit more complicated equation. Not too bad, but. What was the first thing that was done to the x here?
Subtract by 3.
Yeah, it was 3 was subtracted from the x. Good. Subtract 3. After it was subtracted, after 3 was subtracted from it, what was the next thing that was done to the x?
Divided by 2.
Good. Divide by 2, yeah. And the last thing that was done to it?
Added by 7.
Yeah, you added a 7. So now to solve, what do I do?
Subtract 3.
Good. The last thing becomes first. So instead of, not subtract 3, subtract 7. Right? Because you got to go, the last one becomes first. Team, right?
Huh? Yeah.
This one, you do the opposite, stick it up top. Instead of divide by 2, it becomes multiply by 2. And then instead of subtract 3, now it's add 3. So there's 2 reversals going on, right? You reverse the order and you use the opposite operation. But now this gives you the step-by-step instructions to solve for x here. And to prove it, I'm going to run away. No, I'm going to solve it. So we have x take away 3 divided by 2 plus 7 equals 23. my instructions say the first thing is subtract 7 from both sides, right? Now notice, I didn't say both sides, but that's always implied whenever you're working with an equation. Whatever you do on one side of the equal sign, you have to do on the other side. That's to keep it in balance, okay? Leo. Can't sleep in class.
Yeah, I got a nursing ass something. I can't stay and do this.
That is crazy. though,
Talk
like,
to Miss Wan on
Some of these dead-ass no news.
here. So this cancels out, and we get x take away 3 divided by 2 is equal to 23 take away 7 is 16.
Me too. Like the question.
So we did the first thing. Now we have to multiply both sides by 2. Well, we're supposed to multiply the 2 by the top and then divide by that. But really, you're going to have 2 divided by 2. They cancel each other out. That's the whole point of this. So what's left here is the x take away 3 is equal to 16 times 2 is what? 32. Okay? And the last step says add 3 to both sides. Yeah, you're going to get x is equal to 35. And somebody tell me, how do we check this? Plug it back in, yeah, good. So it's 35 minus 3 divided by 2 plus 7 equals 23. What's 35 take away 2? It's 32. 32 divided by 2 is 16. 16 plus 7 is 23 equals 23, right? It actually works, So look, you know, if you have a simple equation, I'm not expecting you to do this every time, okay? But when it gets more complicated, if you get lost, this actually will give you the right instructions every single time, okay? The other thing that's good about this, it sort of explains why we're not going in PEMDAS order when we solve it. Just remember, you're trying to get to the present, so you have to undo everything that was done to that present, right? In the opposite order. So what I want you to do is try the next one, 5b, right? And then it says what happened to x, that's where you write the steps here. And then now reversed, that's where you're going to do this. Try that with the second one. Go by PEMDAS order. So what was the first thing that was done to the x then?